Hello, in this video we will talk about sample correlation coefficients. So when we have paired data sets, for example x and y, so each observation contains xi and yi value. So we may be interested in what's the relationship or linear relationship between x and y. You say if we want to know if x is a very large value, also comes with a very large value of y. Or maybe x, very small value, comes with the paired y value is also very small. So these kinds of information may be shown roughly by a scatter plot. For example, here, x is the temperature and y is the number of defects. So this figure can be roughly said that they have a positive relationship because most often when the points here, for example, x is small but y is also small, and when x is bigger, y is higher, right? So this is roughly showing a positive relationship. But if we want to quantitatively know the relationship between x and y, we may have a statistic. So this comes with the correlation coefficient. So first we have x and y, then we create the mean value of x and y. They are x bar and y bar. Then for each pair xi, we create the deviation of xi and x bar. So each I we will have xi minus x bar and yi minus y bar. So we have the pair of deviation for x and y with respect to their mean value. So if the deviation for x is positive, also comes with the positive value for the deviation of y, then we may think they have positive correlationship between x and y. But if the deviation for x with respect to x bar with positive, then comes with a negative yi from y bar, then we may say the relationship be negative between x and y, right? Because xi larger than x bar then comes with a positive deviation, and the yi minus y bar negative means the yi is small value, right? So large x value comes with a small y value, so this is the negative relationship. So next, here is xi minus xi x bar, okay, xi minus x bar. So if xi minus x bar and yi minus y bar, they have the same sign. So either they are positive, both positive or both negative, then the product of them will be positive, right? But if one of them is positive and one of them negative, then the product of those two will be negative. So the product of those positive means either xi is a small value or yi is also small value. But if xi is a larger value, so y must also be a larger value. So this comes with the scatter plot we showed earlier. So the small x with small y, but the large x with a larger y. So this means the product of these two will be positive. Then we will make the sum of these product for all I for each pair in the data and divided by n minus 1. Then we also divided by the standard deviation for these two, because we will get the scale-free coefficient, because this product is not a scale-free. If very large xi for the xi is million, yi is million, then will be very large value. But xi is 100, yi is 100, they will not be very large. But when divided by their standard deviation for the two, both standard deviation, then the result will be a coefficient between -1 and +1. So this is the formula for calculating the correlation coefficient from the sample. So the numerator is the sum of the product of the deviation for x and y with respect to their corresponding mean value. Then the denominator is n-1. We use n-1 here for the sample correlation coefficient because their degrees of freedom is lost in 1 when calculating this value. So n-1 also times standard deviation of x and standard deviation of y. Then these two will fill in the formula for the sx and xy. These two take a square root, then n-1 will disappear. So the result is like this. The product of these two from their mean value, then the product of the sigma of xi from its mean value take a square, then times the sigma of yi value minus y bar take square. So next we will see some properties of correlation coefficients. So first of all, the correlation coefficient R is between -1 and +1. So for example, the correlation coefficient is 1 means they have very, very high linear correlation, positive correlation between these two variables. And if A and B both are constant, then yi equals A plus B times xi, then the correlation between y and x is 1. Because they have a perfect linear relationship, and the correlation coefficient measures the linear relationship between these two. And also, if B is -1, so their correlation is -1. So be careful, not means their correlation is B. Their correlation coefficient is -1. And also, if R is the sample correlation coefficient for the data between x and y, then A plus Bxi is another variable, and C plus dy is also another variable. Then these two have the same correlation coefficient between x and y, because both are perfect linear variable of x and y. But of course, both B and D are both positive or both negative. So next we should a practical example. From this table, there are 22 observations for the temperature and the number of defects. So if we calculate the correlation coefficient between these two variables, you can see about 0.4189. So they have roughly the positive correlation coefficient. This matches the scatter plot we have seen, but not very high, not very low, moderate 0.41. So thanks for watching our video, and if you are interested in the training for R and Python, we have a website rdatacode.com. Thanks for watching.